Shading refers to the process of applying materials and textures to 3D objects in a scene to give them realistic appearances and effects when rendered. Shading involves defining how light interacts with the surfaces, including factors such as color, glossiness, transparency, and bumpiness. The Shading Workspace is a pre-configured layout designed specifically for working with materials and textures for your 3D models. It provides a convenient arrangement of editor areas that help you visualize and manipulate the look and feel of your objects. 3D viewport is the main area where you see your 3D model. In the Shading Workspace, the viewport typically defaults to Material Preview mode, which displays a basic environment to showcase your materials. Shader Editor is a node-based editor where you create and edit the materials for your objects. You'll often start with the basic principled BSDF and the material output node set up to create materials for your objects. File Browser allows users to navigate and import images, textures, and other resources directly within the interface, facilitating easy access during shading and texturing tasks. The principled BSDF node is like the Swiss Army knife of shading in Blender. It combines several shader types into one, allowing you to control various properties of your material. And the material output node is where the final shading information gets sent to the object's surface in the 3D view. Changing values in node affects how materials are rendered in the final output. Each node represents a different aspect of the material. Slot menu lets you choose which specific material assignment you want to work with on your object. A drop-down menu listing different paint buckets or material assignments for the same objects. When you click the plus button, it creates a new empty slot. This new slot doesn't automatically come with a material assigned to it. Once you have chosen a slot from the menu, clicking New button creates a brand new material from scratch within that slot. You can then define its properties like color and roughness. This is essentially adding a new material. Material Selector lets you change the actual material assigned to that slot, like picking a new color from a paint palette to fill the chosen bucket. The Add New Material button on the right side allows you to add multiple materials. Clicking the X button is a quicker way to unlink a material. Unlinking a material removes the connection between a specific material and a designated slot on your object. To add an image texture, navigate to the location of the image file you want to use as a texture. In File Browser, click and hold on the image file, then drag it into the shading editor. The rendering engine you choose in Blender can significantly affect shading due to differences in how they simulate light, handle materials, and calculate shadows, reflections, and other visual effects. Blender offers three main rendering engines: Eevee, Workbench, and Cycles. Each has its own strengths, workflows, and target use cases, which can affect how shading is handled. Eevee provides real-time rendering capabilities with support for physical-based rendering materials, although it offers limited global illumination and reflection accuracy compared to Cycles. Its strength lies in the interactive previews and fast renders. Workbench is a basic viewport rendering engine offering simple shading modes like flat, smooth, and textured. It lacks advanced shading effects and global illumination, making it suitable for quick modeling and viewport previews. Cycles is a physically based ray tracing engine renowned for its accurate global illumination, reflections, and refractions, with support for complex node-based material editing. It excels in producing high-quality final renders and visual effects. For quicker rendering, there is also the viewport render available in Blender. This feature allows you to generate an image directly within the viewport. The shader editor, also known as the node editor for materials, lets you create complex and customizable materials for your 3D objects. It uses a node-based system where you connect different nodes together to define various aspects of the material. Nodes are the building blocks of the shader editor. Each node represents a specific operation or function, and by connecting them, you create a visual representation of how your materials is built. To pan around the node editor, hold down the middle mouse button and drag. You can use the scroll wheel to zoom in and out of the node editor. Click and drag any of the selected node or nodes to move them together. In shader editor, the default setup typically consists of two nodes. Principled BSDF node. This is the default shader node in Blender. It's a versatile shader node that combines multiple surface properties like diffuse color, specular, roughness, and metallic into a single easy-to-use node. Material output node is responsible for connecting the output of the shader node to the material output of the object. It defines how the material is rendered and displayed in the final scene. In the context of connecting nodes, the starting point and ending point refer to the points on each node where connections can be made. Starting point is typically an output socket on a node. It's where data or information originates from. For example, from the principled BSDF node, the starting point is the BSDF output socket for various material properties like base color, metallic, and roughness. Ending point is usually an input socket on a node. It's where data or information is received. For instance, in the material output node, the ending point is the surface input socket where the shader's output is connected. To add an image texture node, drag the image file from the file browser into the shader editor. Blender will automatically create an image texture node in the shader editor. To link an image texture node to a principled BSDF node, click and drag from the color output socket of the image texture node and release the mouse button over the base color input socket of the principled BSDF node. This action will create a connection between the two nodes. There is indeed a feature called Make Links that allows you to link nodes with compatible sockets quickly in node menu, as color and base color are same data types. Or with the nodes selected, press the F key on your keyboard. This will automatically create a link between compatible sockets of the selected nodes. At starting point, while holding the control key, drag the link away from its socket, release the mouse button and the control key to remove the link. This search pop-up can be used to add a node to that link. You can add a node between two existing nodes by holding down the control key. You can mute a node by selecting it and pressing the M key. When a node is muted, and if the muted node has only one connection, the connection between the muted node and its neighboring nodes will remain intact, but the effect of the muted node will be bypassed. When a node has multiple connections and is muted, Blender prioritizes the upper connection and keeps it intact. To unmute a node, select the muted node, press the M key on your keyboard. You can delete a node using either the delete key or the X key on your keyboard. Or to avoid unlinking your nodes, you can remove a node by holding down the Alt key and dragging it away. Texturing in Blender is dressing up your models with images or patterns. You apply textures to materials, which are then linked to your objects. By tweaking textures and materials, you create realistic or stylized finishes. Texturing in Blender is primarily done through images. You can directly add image textures by dragging and dropping them from your file browser into the shader editor. This is a convenient way to assign image details to your materials. You can drag from the yellow output socket of the image texture node and drop the connection onto the yellow input socket of the base color input on the principled BSDF node. This will connect the color information from the image texture to base color input of the principled BSDF node. Adjusting the metallic value will change how metallic the surface appears. A higher metallic value will make the surface appear more like metal, while a lower value will make it appear more like non-metallic. metal. Changing the roughness value will alter the surface smoothness. A higher roughness value will make the surface appear rougher. Adjusting the alpha value will affect the transparency or opacity of the material. A value of 1 indicates full opacity, while a value of 0 indicates full transparency. Intermediate values will create semi-transparent materials. Hanging these values will interact with the appearance of the texture connected to the base color input. For example, increasing metallic might make the texture appear more reflective if it contains bright areas. UV unwrapping is the process of flattening a 3D model onto a 2D surface to apply textures. It involves creating a UV map, which is a 2D representation of the model's surface. UV unwrapping allows you to paint textures or apply images onto your 3D models. This process is crucial for texturing and adding details to models, especially in game development and animation. You apply textures to your 3D model in the Shading Workspace. This allows you to see how your texture appear on the model's surface and make adjustments to the materials if necessary. After applying textures, you move to the UV editing workspace or UV editor to adjust the UV mapping of your model. You can make adjustments to how the UV coordinates are laid out on the model's surface, such as manipulating individual vertices, edges, or faces of the UV map. When you select a face in the 3D viewport, its corresponding UVs will be highlighted in the UV editor as well. This feature allows you to see which part of the UV map corresponds to the selected face in the 3D viewport, making it easier to make adjustments to the UV layout while simultaneously seeing the effect on the model's surface. This might involve scaling, rotating, or translating UV island or vertices to better align them with the texture or optimize for the better texture resolution. When the UV selection button is enabled, selecting vertices, edges, or faces in the UV editor will automatically select the corresponding geometry in the 3D viewport, and selecting geometry in the 3D viewport will highlight the corresponding UVs in the UV editor. Procedural textures in Blender are textures that are generated algorithmically rather than being based on image files. They allow you to create complex and versatile textures directly within Blender without relying on external images. These textures are generated based on mathematical formulas, patterns, or noise. Blender offers several other procedural texture nodes, each with its own unique characteristics and applications. The Voronoi texture node is commonly used in procedural material creation to generate textures for a variety of effects, including organic patterns, cracked surfaces, and abstract designs. It provides flexibility and control over the appearance of textures without the need of external image files. Scaling in procedural textures can be helpful in maintaining resolution or detail, particularly when applied to objects of different sizes or viewed from varying distances. The factor socket of the noise texture node outputs a grayscale value representing the intensity or strength of the noise pattern. When you connect the factor output socket of the noise texture node to another node's input, you are essentially using the noise pattern as a control signal to influence some aspect of the connected node.